All right, Bryson and Noah, we're sorry you're not here. We'll see if you guys actually watch the video. I guess let's make the secret code word. Secret code word is up. Right? That just makes sense because what we're talking about today. So secret code word is up. So, all right.
That'll prove that you watched this video and know what you're doing.
Except they could have just watched the first 20 seconds and they're like, oh, I got it. Unless I make a different secret code word at the end.
Yeah.
Alright, today is all about solving proportions, which is what this guy had to do to figure out how to get enough lift to lift his house. And no, this is not up. That's why I took the picture with the actual hot air balloon. That's an actual hot air balloon. And that's not an actual house. It's a fake house they made to be able to fly a house inspired by the movie Up. Now, this guy has been flying since before Up was a movie, but then Up inspired, hey, we could fly a house. So today we're going to solve just a few problems about proportions, and then we're going to take that learning and apply it in Desmos to figure out how many balloons we would need to fly a duck, or our friends, or who knows what we want to fly.
Or baby.
So when we have similar figures, that means they are the same shape, just different. Same shape, just different size, right? Same shape, different size. So you and your partner, I forget if this one's on your paper or not, figure out what X would be. Talk to each other about how can you determine what X would be here.
Well, you can see that it's the 75% decrease. Well, it's not 25%. So this is each one of these is 75%. So it's 3 is 75%. 4. So
Man, Caden, you might as well teach this class. Can I call on you to explain this?
yeah, I
But
guess.
if it wasn't like immediately obvious, like is there a way to calculate this? Like if it was like in the millions.
Could you like show work, like if this wasn't as nice as 3/4? Is that what you're asking?
Probably could. You could do 6 over 1.
It's not one.
All right, so bring it back together. Caden had a beautiful explanation that I would like to celebrate and have him share to us.
So, it was a bit too fast for me to completely finish the problem, but, you can see that, the sides of the, B, each side of B is 75% of the equivalent side on A. So, 3 is 75% of 4, 9 is 75% of 12, so you can tell that X must be 75% of 6, which is cool.
So Caden's brain is wired to think percentages, is probably what that's telling us right now. Your brain might not be wired to think percentages. Totally fine. But what Caden said was if I compare 3 to 4, 3 compared to 4 is 75%. Right, so my new shape, it's like if I went to the copy machine and clicked down the zoom to 75%, ran shape A through, it would spit out shape B. But the Desmos activity involving the copy machine is kind of lame, so I decided we're not doing that one. We're doing the one with the balloons. So, and then Soph asked, is there a way that we could actually show, like, what if this wasn't simple? What if this wasn't nice? What if 3 and 4 didn't get along like they do? I know I got an idea of what work we could set up and build to, like, I mean, so, like, this is, like, A. No, this is actually B compared to A is what I set up. Anyone got any ideas of how we could kind of like write this out? We could do a ratio. And wait, what about another ratio? If I use a ratio with 3 and 4, could I make another ratio involving the thing I need to solve? So?
6 and X.
Would I put X over 6 or 6 over X?
You would put X over 6.
Because we put B over A, we need to make sure, and you could put this on your paper, since we put B over A, we need to put the B value, because X came from B, over the A value. And then we said, like a couple days ago, that what will always work is what? cross multiplication, but I think there's another way we could, like, if I have x divided by 6, how could I get x by itself? Isaac? Multiply by 6. So we could cross multiply, but Isaac's realizing, oh, a 6 on top and a 6 on bottom. Well, that'd be 6x over 6, which is really just 1x. And if we multiply over here, straight through top, straight through bottom, so we're going to get that x is equal to, what's 6 times 3? 18 over 4, so, yeah, 4.5. You guys are awesome.
I did this like a really different way.
Yeah.
I got 4 over 3 and then I divided 6 by 1 and 1/3.
Did it still get the same answer? Different ways to get to Florida.
Florida. They love Florida.
So, there are multiple strategies here. Hey, there are multiple strategies here. Hey, there are multiple strategies here.
Hey.
So, real quick, let's answer a couple problems using different things. It doesn't matter whether we put b over a or a over b. And that's actually exactly what Isaac just said. If you put 4 over 3, that's putting a over b. So here, it doesn't matter what you put on top and what you put on bottom, as long as the proportions you make agree with each other. So what we mean by this, and you're going to need graph paper.
Bryson, go get graph paper. Stay with you, Noah.
We have miles and hours and miles. And we're being asked hours. You can put miles over hours, or you can put hours over miles, but you can put miles over miles. And then you're going to have hours over hours. Now I will tell you, it will be easier for your brain if you put both units in one ratio. Notice how I color coded here? And guys, how do we normally talk? Do we say hours per mile or miles per hour? We normally say miles per hour.
Normally.
I mean, you don't have to be normal if you don't want to. So if we do miles over hours, depending on the highway, I think they might be speeding. No, this would be 35, or not 35, 65, right? If we do this math, it would be 65.
Highways allow it. I think.
Most. Yeah, most highways.
It's like 6.
And then would 390 go on top or bottom?
Top.
Top. And work with your partner to see how many hours would that take. There are multiple strategies for solving.
What do you think is
Ren, dropping the mic. If you get that one done, move on to B. B's got a distractor number. What up?
Oh. We're not supposed to add in the thing?
Whoa, that's almost the E word. Careful. I mean, you're right. You're right, but try the next one then. Because then there's a distractor.
Wait, are we supposed to add in the
Alright, so Ren, drop a knowledge bomb on us.
Yeah, well, 130 goes into 390. Distractor, I see the distractor. I'm not paying attention to it.
Ren's like, hey, just times 3. That's all we got to do. Because these numbers work nice with each other. So this would be how many hours? 6. Now in B, what number there don't we really need? Lucy? Yeah, the 15's not going to scale. That only happens once, right? So we pay that once to get in. Excuse me, the thing that scales, or the thing that happens multiple times, is if it's $4 for every ride, and we go on 7 rides. Sam? Yeah, $28.
443 if you add in.
Armando has collected 39 bottle caps in the past 3 months. At this rate, how many would you expect him to have in 5 months? Set up some work to solve that. They might start to not get along quite so well. months. The abbreviation for months is MOS. Just by the way, I know. I don't know. Abbreviation for months is MOS. And I just haven't started using cards yet. Anyone want to volunteer to tell me how you did it? Nick?
So, I realized that 39 goes well with 3, so I divided 39 by 3 and got like 13 bottles per hour. Then I multiplied that by 5.
So this isn't as nice as what we've seen.
There's also what I pretty much did is cross multiplication. Just like I'm pretty sure at its core it's doing the same thing that cross multiplication is. But I didn't actually do cross multiplication.
Because we don't have to, right?
I
We don't have to.
to.
So, yeah, if we get back to our unit rate first, then we can take it from there. Absolutely. 3 limes for 99 cents. How many is in a dozen? 12. Do 3 and 12 work well together? Yeah. So, more like if they work well together, don't make your life harder than it needs to be. But if they don't work well together, make it easier before you try to solve it. We're going to skip E because I want to check these real quick. Okay, nice. You're good, man. Let's go ahead and go to Desmos to make sure we got plenty of time. All right, so people playing along at home, the Desmos is probably unpaused when you look at it. I don't know. But if you want to go do it on your own, that is up to you. I'm going to play music that'll probably get me copyright flagged, so I'm going to stop my recording.